Hello, everyone, and thank you for joining me today. My name is Rayees Ahmad, and I'm so excited to present my article in this prestigious workshop. And the title of my article is A Survey on COVID-19 related fake news detection using machine learning models. I am co authored by Dr. Rana Hashmy, who is a scientist at the Department of Computer Sciences, University of Kashmir. So, before diving it, we want to make the objectives clear. The one of the main objectives of this study is to combine two largest available data sets related to COVID-19 fake news and make them uniform into a single corpus. And we later will implement classical machine learning, deep learning, and the pre-trained language models uh, and then train them on these combined data corpus, that's the uniform corpus, and we later on evaluate and compare the results. So first of all, we want to define the fake news. What we call a fake news: any news item, whether that be on a social media post or any social media article, is called fake when it can be verified from some reliable source to be fake or false. And we are basically focusing on the social media domain, and whether it be Twitter, Facebook, or WhatsApp, or something like that. So whenever we say fake news in this article or in this presentation precisely, we are referring to the fake news on social media. So this fake news is spread, firstly created and then spread. It can be intentional or unintentional. Basically intentional when someone has some financial gains from this financial purpose, the political purpose, or it can be unintentional sometimes, because some people tend to share these fake news without even verifying the facts, and they are unintentionally spreading the fake news. And it can sometimes be just for some fun purpose, uh, to create and manipulate some real news into a fake news, such satirical basically it can be sometimes. And it gets to its first at the times of some important event. Suppose some election is going on, or some untoward incident happens, like some pandemic like situation happens, or like a flood, or this COVID-19. And a lot of study and research has been done in this field, uh, ranging from the manual fact checking to the automatic ones. As this is the era of artificial intelligence, we'll be focusing, and they have proven to be very much useful in this domain specifically for detecting, because manually doing the fact checking stuff and other stuff is very cumbersome and time consuming, and that basically serves no purpose, because when it takes time, till then the news will be spread to the larger masses, and it maybe it causes some devastating effects. So we are in dire need of some good these automatic detection methods. Basically we are focusing on the machine learning methods. And the data sets we are using over here are, the one is the COVID-19 FNI data set, COVID-19 fake news data set. The first one contains 7,588 news items, and the second one contains 10,700 social media posts. They are somewhat balanced, and like in terms of the number of fake and the true news, these are labeled. They have, each news item has a tag, whether it is fake or real news collected from some reliable sources, PolitiFact, or some other sources, which are which are verified to be true, not to be true, like they are reliable. Finally, we combine these two data sets into a single corpus, as discussed earlier. And after that, what models we are studying over here, one is from the traditional ones. We study logistic regression, random forest, KNNs, sport vector machines, multinomial naive bayes, XGBoost, and the decision trees. And from the DLL, deep learning I mean deep learning models, we study and analyze CNNs and LSTMs, convolutional neural networks, and long-term memory models, and a combination of them later on. And from the pre-trained language models, we study Distilbert, Arobert A, and a combination of Arobert A plus BiLSTM. So what features we are studying over here, what features we are using in each of these models. In the case of the traditional machine learning models, we are using TF-IDF features, fast text, and BERT word embeddings. And in the case of deep learning models, we are using GLOVE and BERT word embeddings. And the pre-trained language models rely on their own these word embeddings. They correspond, like each word with this language model has its own word embedding. They have their own tokenizers, so we need to get the text tokenizer using their own tokenizers. Okay, so the experimental step, we are using the vanilla classifiers. We are using the features like TF-IDF, BERT, and fasttext, and the data, the single corpus is divided first of all into test, train, and validation splits. And in terms of the CNNs, we are using a 1D convolutional model. Like the 1D convolutional layers we are using two of them, each with 128 filters and a filter size of 5. We are using BERT and the GLOVE word embedding, and the output from the convolutional layer is passed through a ReLU activation function, and after that we feed it to a max pooling layer, finally a dropout of 0.4 to be precise, and final dense, this sigmoid activated dense layer is used to predict a binary output, because this is a binary classification problem, and we are setting the learning rate to 0.0001 for the compilation purpose. Okay, so when we talk about the LSTM model, we have initialized the embedding layer with the pre-trained GLOVE word embedding. We are using a size of 300, and we are using a dropout of 0.6. And again, as was the case for CNNs, we are using a sigmoid activated function. That is the basic need of this model, because we want to predict a binary value, because we have two classes over here, true and the fake news, and that's why we are using sigmoid activated. We are training the model for 10 epochs, and we are setting the byte size to 64. And again, we are using at last a combination of these two. We're basically defining the CNN as was defined earlier, and before passing the final output to the final dense layer, we pass it through a LSTM layer of dimension 300. And the final ones, we are analyzing the Robert A model, the Distilbert model, and a combination of Robert A plus BiLSTM. The Distilbert is basically a mini version of the BERT model. It is a lighter version. It has the performance close to the original BERT model, but in terms of the resource utilization, it is quite lightweight. It's not that resource intensive. And the Robert A model, it basically removes one of the main objects as a next sentence prediction objective, and is trained with higher learning rates and relatively larger mini batches. A dropout of 0.4 is applied to the output before we pass this output to the final classification head, that's a sigmoid activated dense layer basically. Okay, then we are analyzing a Robert A on a BILS and a BILSTM on top of that, which basically extracts this sentence features, because BILSTM preserves the context better than the LSTM if we compare it with that. Okay, so these are the results out of the classical machine learning approach. The SVM performs the best when used on it, in fact performs best overall, and has an accuracy of 84.29 and an FN score of 84.75. Sorry about the alignment of this, I don't know what's happened. Yeah, so in terms of deep learning models, the combination of CNN and LSTM performs the best when used on the BERT embedding. When BERT embedding is used, basically it has the best precision recall and FN score. and f1 scores 86.50. The language models, the combination again performs the best. Robot A plus the BLSTM on the hybrid model performs the best. Okay, it has an accuracy of 92.34, and the best performing model of all the analyzed models is this one, the Robot A plus the BLSTM head on top of it. So, in conclusion, we see, as is obvious, the pre-trained language models are the best overall, and in case of the deep learning models, the combination of CNN and the LSTM uh, shows the performance close to some pre-trained language models, because what we mean over here is that they perform good overall when compared to the classical machine learning models and the other deep learning models, and this can be a good research direction, like where to start from if new research has to go in this domain. This can provide a good starting point. And what is the future scope? If we talk about the future scope of the study, we are working on the multiple modalities of the news. The text only cannot be a good indicator of whether a news item is fake or true. We have to use other modalities like the some meta features. So if we talk about the Twitter, we have the available all the features, whether they are of the user feature, they are the user features or the tweet features itself, whether it be the number of followers, the number of followees, the friends we mean, and the other stuff, other like the sentiment, we can calculate the sentiment stuff, and other things. So basically we want to say, if multiple modalities are used in this domain, that will be the best thing we can try. Those are some of the references we have used in this article and in this presentation particularly. And thank you very much for listening.